Another scheduling algorithm is the multi-level feedback queue. So this is actually the very important the scheduling algorithm. So which is based on which is the basic algorithm for the current Linux scheduler, the called CFS, completely fair scheduling. So this is the basic of the CFS. 그래서 이제 현재 리눅스 스케줄링 알고리즘이 CFS라는 알고리즘이 있는데 결국은 지금 우리가 살펴볼 이 알고리즘을 토대로 해서 좀 계속 발전되었다고 보면 될 것 같아요. Okay, so the toward a general scheduler is goal to optimize the turnaround time and also minimize the response time for interactive jobs. Okay, here SJF, STCF has a prior knowledge on the workload, assumption 5, but we don't know that assumption, okay? So no prior knowledge on the workload is challenging. So how can the scheduler learn the characteristics of the jobs and make a better decision? Actually, it is the kind of the predict on the future. So learn from past to predict the future. Okay. 이제 MLFQ, 멀티레벨 피드백 큐의 아주 기본적인 구조가 이제 이렇게 생겼어요. So 그래서 한번 보면, so MLFQ's the basic rules are here. MLFQ has the number of distinct queues. Each queue is assigned a different priority level. A job that is ready to run on a single queue. So a job on a higher queue is chosen to run and the use of round-robin scheduling. RR, we already did one about the RR. Round-robin scheduling is among jobs in the same queue. Same queue means the same priority. 그래서 이제 queu가 이렇게 있고 이 priority별로 지금 여기 이제 타스크가 프로세서가 이제 달려 있는 거죠. So each priority queue has the linked list style of the linked list approach for the managing the process. So there so okay, let's see, there are two rules. So if priority A is the larger than the priority B, higher than priority B, so A runs, so B doesn't runs. So this is the rule 1. The rule 2 is the if priority A and priority B, so B and A and B is the process. So each process, so A and B runs in round robin. So round robin means they alternatively run each other. 그래서 번갈아가면서 이제 계속 실행을 하겠다는 거죠. 우선순위가 똑같다면. So 그래서 이제 MLFQ는 우선순위를 이제 계속 이렇게 변경을 시켜요. 이렇게 변경을 시키는데 어떻게 변경을 시키냐면 이제 뭔가 비헤이비어를 좀 보고 변경을 시키는 거고, 여기 보면 이제 일반적인 워크로드를 우리가 좀 구분을 좀 해야 되는데, 보통 워크로드가 인터랙티브 잡하고 CPU 인텐시브 잡하고 두 가지 나눠져요. So you could see that there are two types of interactive jobs and CPU intensive jobs. 보면 알 것 같아요. short running이고 response time을 빨리 해야 되는 거고, 얘는 예를 들어서 IO를 가지고 있는 잡이 이 인터랙티브 잡이라고 보면 될 것 같아요. 그래서 예를 들어서 the example of the interactive job is the includes the mouse, the click and keyboard, or the interact with users. But CPU intensive job, as you might know, that the intensively the use the CPU resource. So the main policy is keep its priority high. For in case of the CPU intensive job, this reduce its priority. Okay. 그래서 우선순위를 좀 다르게 준다는 거죠. 우선순위를 다르게 주겠다는 거죠. 자, 그래서 MLFQ 이제 보면 그래서 Q가 여러 개 있어요. There are a number of Qs. There are a number of Qs. The AQs. So each queue has the priority, higher priority, and the lower priority. 우선순위가 낮은 것과 높은 게 있고, 그리고 각 priority마다 so each process is the assigned to the certain priority queue. Okay. 이제 also let's see the number of rules for the MLFQ. So rule 3, when job enter the system is placed at the highest priority. Okay. So rule 4A, if a job use up entire time slice while running, its priority is reduced. So rule 4B, if a job gives up CPU before time slice, it stays at the same priority level. 그러니까 CPU를 많이 사용하면은 우선순위 낮추고 CPU 많이 사용 안 했으면 우선순위 높여주겠다는 거죠. 그러니까 한마디로 너 여태까지 CPU 많이 안 썼으니까 CPU 많이 쓸 수 있게끔 기회를 주겠다는 그렇게 이해를 하면 될 것 같아요. 그래서 뭐 아니 뭐 이것도 그러니까 좀 직관적으로 충분히 이해할 수 있는 내용들이라고 보면 될 것 같아요. Okay, so if there are only one, if there was only one single the long running job, okay, let's assume there are three the queues. So the first time the the job is executed on the Q2 is highest priority, and so you might notice that there is time slice 10 millisecond. So for the 10 millisecond, the CPU after 10 millisecond, the job is also the evaluated is their own the priority. So as you might know that the the job is executed on the CPU is full their own time slice, then we need to the scheduler needs to reduce its time the priority to Q1. 그래서 우선순위 낮춰야 되는 거죠. 얘가 다 썼으니까. So again, so it consume the 10 millisecond for the CPU resource. Then you also need to reduce the time slice for the next stage to Q0, the lowest priority. Then it executes the long time to finish the execution for the in the lowest priority. 그래서 우선순위 끝날 때까지 이제 계속 이렇게 실행을 하는 거죠. 그러니까 뭐 하나만 있으면은 이제 뭐 사실 간단하죠. Okay, let's assume that there are two the process. The job A is a long-running CPU intensive job. It's the black marked, and job B is short-running interactive jobs. 20 millisecond runtime. Okay, so A has been running for some time, so that's why A is already A's priority is already Q0 because it has been running long time. 어쨌든 오랜 시간 동안 자기는 이제 실행을 했으니까 가장 낮은 우선순위 작업을 하고 있겠죠. 쭉 하다가 보면 B가 이제 B가 이제 실행을 하겠죠. 이 시점에 이제 실행을 할 거예요. 자, 이 시점에 실행을 하다가 자기가 어때요? 10ml를 다 썼어요. So the job B the execute this the job for the 10 millisecond for their own the time slice. So we need to reduce the priority to Q1. So also Q0 is also the job B is also has higher priority than the Q0. So job B is already could be executed again. 그래서 다시 실행할 수 있고 어떻게 해요? 또 자기 신밀만큼 실행을 다 하면은 얘는 이제 자기 실행이 끝나는 거죠, 뭐. 자기 실행 끝나는 거고 그리고 나면 남은 시간 동안 이제 얘가 실행할 수 있겠죠. 오케이? Okay, so another example for the example 3, what are if there are a lot of IOs? Okay, job A, a long running CPU intensive job. This is A. Job B is an interactive job that needs CPU only 1 millisecond before issuing IO, performing an IO. Okay, so I think you might confusing the length of the bar is only 1 millisecond. 그래서 1ms만 지금 실행을 한 거예요. 이게 이제 아마 여러분들이 좀 헷갈릴 수 있는데 이 길이가 여기서부터 여기까지 50ml이긴 한데 이게 길이가 좀 뭔가 단위하고 좀 안 맞는 것 같아 보여도 좀 이 표현을 이렇게 했어요. 얘가 이제 1ms라고 보면 될 것 같아요. 1ms 하고 그리고 나서 입출력 IO를 실행시켰으니까 어때요? 기다리는 동안에 이제 잡 A가 실행을 하는 거죠. 그리고 나서 얘는 또다시 자기 시간을 다 못 썼으니까 그대로 유지하는 거죠. 다시 이제 자기 그 실행하는 거죠. 이 이상에서. So job B do not spend their allotted time slice because they only spend 1 millisecond for the CPU resource. Then the scheduler keep the priority as a Q2. Again, Q2 has the higher priority to run the CPU resource, to take a CPU resource. 그래서 이제 계속 그러니까 잡은 계속 높은 우선순위 계속 가지고 있는 거죠. 계속 가지고 있는 거죠. 그래서 이제 이렇게 보면 될 것 같아요. So the MLFQ approach keeps an interactive job at highest priority. Okay? 이렇게 보면 될 것 같고, okay, this is the very basic of the MLFQ scheduling algorithm, but there are a number of the problem. And the first problem is starvation, and the second problem is game the scheduler, and another problem is also a program may change its behavior over time. If there are too many interactive jobs in the system, so long running job will never receive any CPU resource. The starvation problem. And the second one is the game the scheduler. Is kind of a tricky. It's bad behavior of the job or certain process. After running 99% of the time slice and the task issue or IO operation, then the job gains a higher percentage of the CPU because it keeps the priority. But the problem is they already spend a CPU resource for the 99% of the time on time slice, but it's tricky. Okay, and also the program tends to change the CPU bound process to IO bound process. Okay. Okay, let's see the example. So rule 5. So we need to solve this kind of the problem, starvation and game the scheduler and this kind of behavior. We need to solve these problems. So first, the solution is the priority boost for the starvation problem. 그 스타베이션 문제를 이제 해결하려고 priority boost라는 걸 이제 만들었어요. 얘는 after some prior time of S is a certain time length, so move all job in the system to the topmost queue. 그래서 이제 직관적으로 알 수 있는 게 okay, let's see the left figure and the right figure. You could compare to this figure. 지금 보면 이 왼쪽 그림에서는 그러니까 이 두 개의 프로세스가 okay, you might see job A, job B, job C. Job B and job C is an interactive job, and they use their CPU resource, but the job A get a starvation has the starved problem. 그래서 얘는 이제 실행을 못 하는 거죠. So job A could not be executed on the CPU because it's still on the lowest priority problem. But the solution is the priority boost. If a certain time length, then all all jobs are moved to topmost queue. Then job A get a chance to be executed on the CPU since job A has the highest priority. So that's the solution for the starvation problem. Okay. Okay, so the second problem is the game the scheduler. It's cheating, kind of cheating. How to prevent the game of our scheduler? Solutions. Okay, so we could rewrite rule 4 and rule B. Okay, let's see. Once the job use up its time allotment, then time allotment at given level, then we could reduce their own priority. 그래서 이제 결국은 실제로 자기가 할당받은 타임 슬라이스만큼 다 사용했으면은 결국은 우선순위를 그냥 줄여주는 거죠. 우선순위를 낮추는 거죠. 지금 보면 저 왼쪽에 있는 그림은 문제점이고 오른쪽에 있는 그림은 솔루션이죠. So you could see the problem and the solution. So job B, there are two jobs, job A and job B. Job A and job B. Job B executes a run on CPU. The own time slice, let's say 99% of time slice, then issue the IO. So here, issue the IO, and the job A has chance to run the execution on the CPU. And again, job B has still highest priority, so it could get chance to run on CPU. Then again, it's the long time job B has the highest priority. But our solution is once job B has their own time slice, okay, let's see, is 99%, and then again 1% they execute, then we could reduce their own time slice. Then the job B's priority is reduced to the Q1. Again, job B has to execute this manner. So again, to job B, its priority is the reduced on the Q0. So then we could prevent this kind of the gaming of our scheduler, so we could prevent this kind of the bad behavior or trick. Okay. Okay. Uh, okay. And another, okay. So, uh, okay, let's see the another other issues as well. 그래서 이제 다른 또 이제 이슈들을 좀 보면 우선순위 높은 애들은 타임 슬라이스를 그냥 가능하면 좀 작게 주는 게 어떻게 보면 좀 더 좋아요. 그러니까 좀 더 좋다기보다는 뭐라고 해야 되나 좀 더 현실적이라고 보면 되겠죠. 왜냐면 걔네들은 어차피 조금밖에 안 쓸 거니까. 그리고 우선순위가 낮은 애들은 타임 슬라이스를 좀 길게 주는 게 차라리 좋다. 왜냐하면 어차피 얘네들 한 번 받으면은 받을 기회들도 별로 없고 또 한 번 받으면 뭐 오래 주면은 자기들 이제 오래 사용을 하고 또 다음 그러니까 낮은 애들은 어차피 CPU만 계속 사용하는 애들이니까 길게 주는 게 차라리 좋을 거다. 어. So so we could consider the lower priority and longer time slice. So this is the figure for the adjusted the time slice. So actually this is the natural uh, behavior or the natural decision for the process behavior. 어, 그래서 이제 실제로 이제 솔라리스라는 previous Sun and Oracle. 이제 현재는 이제 오라클이라는 회사가 있는데 이 선이 오라클에 이제 합병됐죠. 이제 멀지도 됐어요. 멀지 됐는데 결국은 이 선이라는 회사가 솔라리스를 이 솔라리스라는 이제 OS예요, OS. 어. 그래서 이 솔라리스라는 OS에서는 결국 이 MLFQ라는 얘를 그러니까 구현을 해서 사용을 했어요. 그래서 Q가 60개 있고 그리고 뭐 이 저기 뭐야 얘는 우선순위 높은 애들은 20ms 정도 주고 나머지는 뭐 100ms 정도 주고 뭐 100ms 정도 주고 그리고 이 아까 우리가 봤던 부스티드 이 타임 부스트, 프라이어티 부스트는 한 1초에 한 번씩 주는 이와 같은 정책으로 솔라리스에서 이제 구현을 했어요. So you could see that this is the specific implementation criteria for the Solaris, the OS for the MLFQ implementation. Okay. Okay, let's see the summary of the MLFQ. So the refined set of MLFQ rules, the rule one like this. And rule two, rule three, we already know that. Rule four, the once the job use of its time allotment at the given level, so its priority is reduced. And rule five, also after some time or period S, move all jobs in the system to the topmost queue. So this is the final rule of the MLFQ. And we could see that the beauty of the MLFQ, it does not require prior knowledge of the CPU usage of the process. So because it is a practical the assumption, we don't know any other prior knowledge of the CPU, the process behavior. Okay, I think that's all for the MLFQ scheduler. I think I'm gonna show you some kind of the simulation for the MLFQ. So I also would like to give you an assignment for the next assignment. Okay. Oh, okay. So just wait. Okay. You could have you had a chance to download this kind of the resource from the GitHub for the from the textbook? No, nobody. Okay. So there is the GitHub for the this for the some kind of the simulator for this book. Okay, let's see. So there is MLFQ. Okay, let's see this one. I think I need to show you. So this is our textbook for the MLFQ. So we already run this kind of the context, and yeah, here. The book also provide the homework and simulation. So there is a MLFQ and Python simulator. So allow you to see how MLFQ scheduler presented in this chapter behaviors. So let's see the README file for detail. Okay. So here, allow you to see how MLFQ scheduler presented in this chapter. As before, you can use the generate the problem yourself using the random seed or use the construct or carefully designed experiments to see how MLFQ works under different circumstances to run program types. Okay, so this kind of we could type this command, and also yeah, let's see. MLFQ, we could give argument J3. Okay, what is the argument J? Jobs, number of jobs. Okay, yeah, number of jobs 3, and the Q also. Okay, yeah, job 3 and Q3. So we could also to specify how many jobs, and how many Qs. Yeah, like this, and the Q length or the time of boost, IO time, like this. And this scheduler could calculate the response time and the turnaround time. Okay.